We have two algebraic variables with the same base. This occasion the base is x and the x, but the exponents are different. First, let's try the key skill. What we do is we keep the same base, add the two exponents. So when we have same base, different exponents, we multiply, keep the same base, add the two exponents. Done. Verification. X cube, x to the power of 3. That means 3x has to be multiplied with each other. Sorry, the final answer is x9. 3x has to be multiplied with each other, and the white x to the power of 6 is 6 number of x has to get multiplied with each other. Altogether, we have got 1, 2, 3, 4, 5, 6, 7, 8, 9x that has to get multiplied with each other. Top one is x9, x to the power of 9. The bottom one is x to the power of 9. Another example, every x, when we don't see any exponents that are invisible, that means there is 1. Or we can have x to the 1, x to the power of the 1 plus the 1 plus the 1, and all the 6 ones together. Still, it's x to the power of 9. So this second two line is for verification to build our confidence, but the process we follow is when we multiply, add the two top exponents. When we divide, we do the subtraction, the top minus bottom exponent. So x6 divided by x cubed, x to the power of top minus bottom exponent, and the answer is x to the power of 3. Verification. 6x on the top has to get multiplied with each other, and 3 number of x has to get multiplied with each other. And when we cancel 1x on the top, 1 on the bottom, 1 on the top, 1 on the bottom, so the 3 number of x's and the 3 number of the bottom x's, they cancel with each other. The rest of the value is 3x on the top, which is x to the power of 3. And that's the verification. But the process we use is subtract the top minus bottom exponent to run the division. Now, what if when the division is, the top number is a smaller number, the top exponent is a smaller one, and the bottom is a bigger one. It's an exponential fraction. Exponential fraction is the number on the bottom will have a bigger exponent, the number on the top will have a smaller exponent after the simplification. But as we follow the process, the division, top minus bottom exponent, we end up with x to the power of -3. It's a new kind of notations. But the simplification is on the top is 1, on the bottom is, this is called exponential fractions. So it's 1 over x cubed. Verification. 3x on the top has to get multiplied with each other. 6x on the bottom has to get multiplied with each other. And we cancel the top 3 with the bottom 3. The final simplified result is 3x on the bottom. 1 over 3x. 3x means 3 number of x's. It's not 3x. X plus x plus x is 3x. X times x times x times x is x to the power of 3. So it's 1 over x cubed. That's the verification. Very easily done. The next key skill required is we have a fraction in the parentheses and it's another power outside the parentheses. So it's x to the power of 2, everything to the power of 3. How we simplify it? By the law is x to the power of inside times outside exponent. What's the proof? X to the power of 2 powered by 3. It means 3 number of, by the way, the final answer is obviously x to the power of 2 times 3 is 6. So x to the power of 2 powered by 3 means we have 3 number of x to the power of 2 has to get multiplied with each other. And another law, when we multiply exponents with same base, we add the 3 2's. Is the 2 plus 2 plus 2. Answer is x to the power of 6. Another verification, we have 2 number of x from the green one, 2 number of x from the yellow one, and 2 number x from the white one. Not addition, multiplied with each other. 1, 2, 3, 4, 5, 6 number of x has to get multiplied with each other. And the process is inside times outside exponents. So it's all the verification there, and we will apply it on complex situations. We will learn another skills over here. What about any value, any variables, any number to the power of 0? So let's start with the first one. What if we have x5 means x to the power of 5 divided by x to the power of 5. Anything same, divide by anything same, the answer is 1. But if we follow the laws of the exponents, it can also be written as x to the power of top minus bottom exponent. So it's x to the power of 5 minus 5. We end up with x to the power of 0. We also know same value over same value, the answer is 1. So we can relate these two values. Obviously, these two values is same, two different notations. So we come to a conclusion, x to the power of 0 equals 1. Another example using number, 3 to the power of 2 divided by 3 to the power of 2 is the same thing. Same divided by same value, the answer is 1. But algebraically, if we use the exponent law, it can be also done by 3 to the power of 2 subtract 2, top minus bottom exponent, and we get 3 to the exponent of 0. On the other hand, if we divide the same two values, 3 to the power of 2, 3 to the power of 2, we get 1. We can also write 3 to the power of 0 is equals 1. We are coming to a final conclusion. X to the power of 0 is 1. 3 to the power of 0 is 1. Now we use something, a group of values. It's a group of value inside the parentheses, which is x plus 1. Denominator is same. Exponent is the same on the top. Exponent is same on the bottom. So the whole group x plus 1 powered by 3 and the group x plus 1 powered by 3. By exponent law is the same base, x plus 3 should be top minus, the power is top minus bottom exponent, and the value is x plus 1 to the power of 0. By definitions, we know this is going to be a 1. So we can write x plus 0 is 1. Or we can keep a blank bracket just to come to a verification. Anything we put, anything means any value, when it's powered by 0, the answer is 1. It's a very important conclusion to handle or simplify exponents. Another skill we have to understand is negative and a number with exponents. Just be careful, this negative is outside, so it's negative of a green value, and the green value is 2 to the power of 2, which is a 4. Basically, it's negative of 2 times 2, which is a negative of 4. Now, before we come or describe a conclusion, what if we have a negative 2 and that is powered by 2? This negative in the bottom and this situation is different. This negative is inside the parentheses and it is affected by this exponent. And the value is negative 2 times negative 2. Two negatives multiplies, becomes a positive, and 2 times 2 is a 4. So on the top it was negative 4, on the bottom is positive 4. That exponent was outside. Sorry, that negative sign was outside the exponent zone, and this negative is inside the exponent. What about if we have negative of 2 to the power of 3? Like the example of the first one, it's going to be negative of 2 times 2 times 2, and the answer is negative of 8. What if this negative exponent is now inside the exponential zone, and this exponent is 3? It's going to be negative 2 times negative 2 times negative 2. 3 negatives, negative times negative is positive, positive times negative is negative, but this time the final answer is negative. We have a difference. When we had a even exponent, the final answer was positive, but when we have a odd exponent, the negative remains to be negative. So we come to a conclusion, very important point. It can be 2, 4, 6, anything even. Final answer positive, depends on the number and the other values. And the odd one can be 3, 5, 9, 11, anything. The final answer is going to be negative. That's the important part. And the number, final numerical value will depend on the number and the exponents. So if we have a negative powered by even exponent, our final answer is positive. Very important. And if we have a negative powered by an odd exponent, the final answer is going to be negative. If it's positive, positive always remains to be positive. But these are the two very important points we should learn to simplify exponents. Now we have done it in the very beginning, deciding of negative exponents. So negative 3, sorry, x to the power of negative 3 divided by 1 is same as just x to the power of negative 3. The process is we just write 1 over x to the power of positive 3. So we can switch a negative exponent to 1 over the same base, but the exponent becomes positive. Or if we have a x to the power of a positive exponent, we can write it 1 over x to the power of negative exponents. So it gets reciprocal and the exponent gets negative. Very simple. The proof of the second one. How can we prove that 1 over x to the negative 3 is equals to positive of x to the power of 3? What we can do is write the 1 over this x to the negative 3 is 1 over x to the positive 3. So 1 divided by another fraction, which is same as 1 divided by the fraction. We keep the 1, change the sign to multiplication, make it reciprocal or flip the fraction, x cubed over 3, and the final answer is 3. So that's the proof. X positive 3 equals to 1 over x negative 3. Now we have to multiply two values inside the two parentheses. The first value is 12 times the a to the power of 2 times the b to the power of 3. Everything multiplied by another parenthesis value, which is 2 times the a to the power of 4 times the b to the power of 2. This is not taken as a distribution. There is no positive or negative sign. Every value is going to get multiplied with every value. Basically, the sense of this is 12 times the a2 times the b to the power of 3 times this 2 times this a4 times this b to the power of 2. And the simplification is same like term gets multiplied with each other, and the different terms will be written as multiplication or factors. So 12 times 2 is 24. A to the power of 2 times a to the power of 4 is a to the power of 2 plus 4. B to the power of 3 times b to the power of 2 is b to the power of 3 plus 2. That's the real sense, but practically what we do is we just multiply 12 times 2, write the final answer. A2, A4, write a to the power of 4, 2 plus 4, 6. B3 with B3 means b to the power of 3. B3 times B2 is b to the power of 3 plus 2, 5. That's the final answer. Another example of division. The green value has to be divided by the white value. It's a division and it's an algebraic division. So we have to write it in a fraction mode. So the green value is 8 times x7 divided by, we just copy and paste this value, which is 2 times the x cubed. Now we keep the top number as, we just write it as a factor 8 times x to the power of 7. This value, we have to take the parentheses out. When we do that, it's going to be 2 to the power of invisible 1 times 2, inside times outside exponent, x to the power of inside times outside exponent. And the final simplification is 2 to the power of 2 is 4, x to the power of 3 times 2 is 6. Now the 8 gets divided by the 4, which is a 2. x7 gets divided by x6 is x to the power of 7 minus 6, which is x to the power of 1. Or we can do it in a different way. Copy and paste the top, this bottom, straight away take the parentheses out. 2 to the power of 2, which is a 4, x to the power of 3 times 2, inside times outside, 6. And it's the same value. 8 divided by 4 is a 2, and x7 divided by x6 is just x to the power of 1. And we are done. We have another example, looks complex, but is the same process. 30 times a to the power of 2 times b multiplied by a parenthesis value inside the parenthesis powered by 2, which is twice ab, divided by 5ab to the power of 2 times 6a times b. Just the sense of it is 30 times the a2 times the b. Simplify the exponents is going to be 2 to the power of 1 times 2, which is a 2 to the power of 2, which is 4. There is no positive, negative, it's not distribution, it's just multiply each values. We are simplifying the exponential values. A to the power of 1 times 2, which is a to the power of 2. B to the power of taking the exponent out, taking the parentheses out, 1 times 2 is b to the power of 2. and everything gets divided by 5 times 6. We will multiply the 5 times 6 later. Is the 5 times a times the b. So every value we just use the dot just to show its multiplication. And when the numbers are spaced out, it's easier to understand that we just deal with the same like terms. Now on the top, the number first, then we will deal the a, then we will deal the b value. So the number like term is 30 times 4. We are not changing the 30 times 4 because we can see there is a 30 coming in the denominator. We don't want to make it bigger than divide it by the 30 again. So keep the 30 as well. Write side by side with the 4. The a value, power 2 is a to the power of 2 plus 2, 4. Power 1, b, power 2 with the b is b to the power of 1 plus 2, 3. And the denominator, the reason we see a 30, so let's multiply the 5 times 6 as a 30. The a power 1, another a power 1 is a to the power of 1 plus 1, 2. B with the power 2, b with the invisible power 1 is b to the power of 3. Now it's time to simplify a top and the bottom. This 30 gets cancelled with this 30, so the top number is 4. And this a to the power of 4, and that will bring us a to the power of 2. Top minus bottom exponent, right? 4 minus 2a to the power of 2. So the final answer is 4a to the power of 2. And we are done. We are having another example, fraction with the power, another fraction with the power, another fraction with the power. But the advantage on this one is if the values were different, it would have been a very long process. We had to simplify every single part. We are not thinking of this at the moment. Every value is same. So let's think of something with a blank. It helps us to understand it much more easier. We'll just take the value out. If those blank values were same, powered by 4 on the top, powered by 3, and powered by 7 on the bottom. The top part, as long as the values are same, is going to be the same value. Add the two exponents. Bottom is just copy and paste. Finally, whatever the value on the top and bottom, as long as they're same, is going to be same value powered by 7, same value powered by 7. And the answer is 1. Anything same divided by anything same, the answer is 1. So what we do is, we just simplify the top. 2 over 3, same base, add the two exponents is a multiplication. So 4 plus 3 is 7, and the bottom is copy and paste. Same value divided by same value, and the answer is 1. Too simple, too easy.